Yes. Then after a request, the particular process which required this IO will go in busy waiting and until the particular IO operation is complete. So the very first action is behalf of a process. The processor is going to send a request for IO module for the IO operation, and even before the IO operation is initiates, the particular process which requests for this IO will be kept in busy waiting. So this busy waiting will continue until the particular IO operation is completed. So as soon as the IO operation is completed, it will receive the result, that is whatever the IO operation is carried out, and immediately which can resume. So unless the particular IO operation is complete, the particular process will be in busy wait. The second category is interrupt driven IO. Even here you can find that the processor is going to send a request to the IO module behalf of a process, but here only the difference is that it is going to be initiated by an interrupt, and in before that it is just by a programmed IO. So here the difference is that interrupt is introduced. So now here there are two possibilities. Whenever it goes for handling or doing this IO by interrupt driven IO method, there are two possibilities. Say either the process may go in busy wait, or the process may be in execution. Say how it can be decided. The particular instruction which requires IO operation will be checked whether it is of blocking or non-blocking. If it is found that particular instruction which requested for IO operation is non-blocking, so it can proceed. So there were no busy waiting. So the IO operation is handled by IO module, and even the particular process go for to do its usual task. And the second is blocking. Say in case if the instruction is found that it is of blocking mode, then even before the IO module to start the IO operation, that particular operation, the process will be kept in blocking, that is busy wait. So it is same as like of our earlier programmed IO. So the interesting third method is of DMA, direct memory access. So the main difference between these two is, first of all, this is without interrupt, and the second one is with interrupt, but these two are with the help of processor. The IO operation is carried out with processor. So during the course of action IO operation, in these two programmed IO and interrupt driven IO, the processor is in busy state, right? But in DMA, interestingly, the DMA avoids the interference with the processor. The processor is required. It is interfere with this IO operation only at the beginning and at the end. So we will see how it is. I have drawn a block diagram of DMA. So here you can find that there is a data count register and data register, address register. So these are connected with the data line, and here you can find that control logic. This control logic is have request DMA. There is a request from the processor. The process, whenever a processor identified that there is a need of IO operation, the processor can request for DMA for doing IO operation. Then the DMA will send an acknowledgement. Yes, it is free, so it can carry on. So in such case, the DMA will send an acknowledgement to the processor. Yes, I can carry the task whichever are requesting. Next is interrupt. This interrupt signal is for the purpose of to acquire the system bus, because the system bus is utilized by the processor. So if the DMA wants to do data transfer, either input or output, so the DMA need system bus. It needs to take a control. So to take a control, the DMA is initiating an interrupt. And Next is read and write. So this read and write operation is, it will be informed by the processor. Upon requesting, it has to inform that whether it needs a read and write. And these three are for the purpose of how exactly it can carry out the input and output operation. Say in either it may be an input or output operation, we have to specify which particular IO device is, right, by the address. Each and every IO device will have its own unique ID. It is called an address. Or you can more specifically, we can go by in which particular address we want to read or write. So this will be informed by address register. So the appropriate address in which we want to either read or write will be informed by address register. And how many bytes or blocks of data has to be read or either written, it will be informed in data count. So at every step, data count register will keep on decrement. So whenever it reaches 0, that is the end of IO operation. And the data register is, say, in the case if the processor needs to write something, so the data whichever want to write in some particular locations will be kept in data register. Then it initiates write operation. So the data whichever are stored in data register will be stored in the address specified by this address register. Say in case of read operation, it will be empty initially, and the location in which from we want to read will be loaded here. For example, 2000 from some external devices, from the 2000 location we want to read a data. So the 2000 is here, and there will be a read operation is initiated. So the data whichever are read from that 2000 locations will be found in this data register after some periodical time, right? There are some sort of time was required. So and during that time it has to wait. Then after that it can find the data in data register.